Hello everyone, welcome back. Today we will be solving one LeetCode question. Find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 and n time. For example, this array might become this array if it was rotated 4 times, or it will become this array if it was rotated 7 times. And at the end, you want to return the minimum element in this array. And also you must write an algorithm that runs in O of log n time. Let's take a look at the example. Here we have the array 3, 4, 5, 1, 2. And the answer is 1 because 1 here is the minimum value in this array. And the original array was 1, 2, 3, 4, 5, but it was rotated 3 times. Here another example. We have the array 4, 5, 6, 7, 0, 1, 2. And the minimum, the smallest number or the smallest element in this array is 0. And the original array was 0, 1, 2, 4, 5, 6, 7. And it was rotated 4 times. How do we solve this problem? Remember, the goal here is to find the smallest element in the array. And we want the runtime to be O of log n time, which means we cannot use math.min for the entire array or loop through the entire array to find the smallest element because it will be O of n time and we want O of log n time. To search element in the array, we can use binary search because binary search work on a sorted array and the runtime is O of log n time, which we want. However, this question is a bit tricky because even though the array is sorted, it was rotated. Well, the binary search still works if we do some modification. Let's start with the normal binary search implementation and then we can modify it along the way. We will initialize two pointers, I and j. I will be the first element of the array or the first index, and j will be the last index, so it will be num.length -1. This will give us the last element or the last index in the array. And we also want to keep track of the final min, the smallest value in the array, and we can initialize it with infinity, which is the biggest number in the JavaScript. While looping, we want to get the middle index, so the mid IDX will be equal to I, the index I plus the index j divided by 2. And then we will keep track of the minimum number. We will update our final min between the final min and the mid number. So here, I will be the first element here and j will be the last element, which is 2. So I here is 0 and j here is 0, 1, 2, 3, 4, 5, 6. So 0 plus 6 divided by 2 equal to 3, and 3 should be at this element. So this one is middle, and we want to check between 7 and the current final min, which is infinity, which one is the smallest. Of course 7 is the smallest, so we update our final min to be 7. Now come to the tricky part. How do we move our pointer? How do we move I and j? If the array is not rotated, we know that everything on the left side will contain all the smallest number. And everything on the right side will contain all the largest number because it is sorted in ascending order. However, in our question, our array can be rotated. And how do we know which side, left side or the right side that contain the smallest value? So we can check the last element and the middle element to see which one is bigger, because normally the last element here should be bigger than the middle element. And if the last element is smaller than, that means this portion will contain the smallest value. And we don't have to check this part here because we know that this part will have the smallest element. Here we will check if the right number is smaller than the mid number. If it is smaller, then we can move our left pointer to be at the mid +1. So if this one is smaller than the mid number, we move our pointer I here to be the mid +1, which is here. And if the last element here is not smaller than the middle element, we can just move the j pointer here to be at the middle index -1 because we want to check this part instead. Here, else, right index will be mid -1. And at the end of the looping, we can just return back the result, the final min. Let's code out the solution. Let me get some space here. I will initialize the left index to be 0 and the right index to be the last index, which is the array.length -1, and also the final min that's gonna be our final answer, and I will initialize it with infinity. And while left index is smaller or equal to the right index, we want to check the middle index. So the mid index here is mass.floor left index plus right divided by 2. And we want to keep updating our final min that will be equal to math.min, final min, and the nums at the middle index. And while looping, we also want to move our pointer. So we want to check if num right here is smaller than the num at the middle index. If it is smaller, then we know that we want to check only at the right part side. So we want to move our left index to be at the middle index +1. Else, if it is not smaller, which means it is just a normal array, so we can just move the right pointer, the right index, to be at the middle index -1. And at the end of the loop, we can return back the final min for the final answer. I just noticed that this one should be right index, not just right. Let's check the result. So what is the time complexity for our implementation? Time here is O of log n. Because we are using the binary search and we don't actually search the entire array, we just search only half of the array at a time. O of 1, because we don't use any extra space at all. Hope you guys enjoyed it. See you next time.